Well, good evening, and welcome to Kopernik Observatory Science Center. My name is Drew Desker. I'm the director here. It's great to see some familiar faces and some new faces. And also want to welcome those people on the live stream. I think we have 16 viewers on the live stream. So, and people are still coming in from the parking lot. So just as a matter of interest, who's here for the first time? All right, a good number of you. All right, very good. Well, we are actually approaching our 50th anniversary. Back in 1973, a group of Polish immigrants, people of Polish heritage here in the area, wanted to commemorate Kopernik's 500th birthday, and as I like to say, instead of buying a statue, plunking it in the park, they said, let's do something. And so they built the original observatory, and we have been running it as an informal STEM education center since then. We do a number of things. Like right now, we're actually in the middle of our summer camp sessions. We've this year in particular has been great. Almost every one of our summer camps is full, and we have another 2 weeks of camps before we finally finish. And next week, actually, we have an exciting camp. It's called Welcome Aboard the International Space Station, and it's an opportunity for kids that are entering 4th and 5th grade in this fall to learn about what it takes to become an astronaut, what kind of training they go through, what kind of work they do on the International Space Station. And part of this camp is we have an opportunity to have our students talk to an astronaut on the International Space Station as it's flying by. We have a ham radio station here, and we petitioned NASA to get what we call a school contact. And so our students will get an opportunity to ask a question of astronaut Bob Hines, who is currently on station. Basically, we're going to use our ham radio station to talk to the ham radio station on the ISS, and then Bob Hines is going to answer through that ham radio station, and we will be live streaming that on our YouTube channel. So that is scheduled for this Wednesday, right around noontime. So for those of you who are watching on the live stream, check out Wednesday afternoon. Well, Wednesday at noontime. Actually, 11:45 we sort of start the program, and the contact will begin around about 10 after noon. So again, the summer camps are just one of the things we do, but Friday nights is really our main way to engage with the public. And it's an opportunity for us to have people talk about a wide range of topics. It's not just always astronomy. We've had people talk about the science of taste. We've had people talk about the science of music. Why does a trumpet, an oboe, and a violin all sound different playing the same note? So it's an opportunity for you to learn more about how the world works and how the universe works. We also do school programs. We do scout programs. So this has really been an opportunity for to reach sort of a wide range of audiences. Now, back about 2.5 years ago, when COVID hit, we were sort of we had to put all of our public programs on pause, and we thought, well, maybe this a couple of weeks we'll be back to normal. Well, here we are. So after about 2 months of that, we decided, okay, we need to do something. So we started to live stream. So we would have our presenters zoom into us, and then we would put it back out on the live stream. Now now that even though we're having people present back in person again, it's an opportunity for us to continue this live streaming. And in fact, Jeremy Cardy, who is our live stream engineer this evening, I'll give you a little. There's Jeremy back there. Jeremy, back in May, came up here and put a camera on one of our telescopes, and he basically did a whole live stream of the lunar eclipse that was happening. Did anybody see that lunar eclipse that was here? Well, at one point, we had over 25,000 people on our live stream. The chat was just flying by, and people were saying, and throwing no shade at NASA at all, but people were saying, we left the NASA's live stream to come to yours because we like yours better. So it's great to, we now have over almost 11,000 subscribers, and it's just a great opportunity for us to do outreach and engaging people. And also what was nice is also those people that we sort of started engaging with on the live stream when we couldn't have people come in here, and now those people are able to actually be here, so we actually get to put a face to the screen name that we saw. But anyway, tonight we're going to have an opportunity to delve into science fiction and how it ultimately translates into science reality. Nicholas Davis is an author. He actually met one of our educators, Tish Brizzi, at a Conklin Con, I think back in May or June, back in May, and thought, well, you know what? People come up with ideas for things, and sometimes they turn them into books, sometimes they turn them into engineering marvels. And so Nicholas is going to talk about the work he does as a science fiction writer, but how it ultimately maps into reality. So I'm going to ask Nicholas to come on up here, and we'll get his presentation started. So give me a second to turn on the... All right, there you go.
Hi, thank you. My name is Nicholas Davis, and I'm a science fiction writer. I've written 15 books. I have a series called Dimension Lapse series, and I have a fantasy series as well. And I started writing professionally in 2014. I've had an interest in writing since I was 12 years old, inspired by my 7th grade English teacher. I also maintain and monitor a website for local authors, as well as belong to a local touring group, author group called the Wandering Wordsmiths. I have attended local Comic-Cons in New York, Massachusetts, Pennsylvania, and attend at least 25 book signings a year. I have a paralegal degree, and I took some courses at Morrisville in journalism, and I'm from Syracuse, New York. I'm the son of a Protestant minister and one of 8 kids. I'm married to Nancy, who's with me tonight for 20 years, this September, and I have a 29-year-old daughter named Kelly from previous marriage. Tonight, I am here to talk about the history and the types of space travel, as well as writing science fiction. If you have any questions, please wait until the end of the presentation. I'll be glad to answer them. Tonight's presentation is entitled, Are We There Yet? And of course, the answer is no. We got a long ways to go if we want to reach the stars. And during this talk, we'll discuss the current types of travel, as well as future technologies, and determine whether they're feasible or not. Then, for any would-be writers, we'll have a brief tutorial pertaining to writing science fiction. I hope you enjoy it. We're going to start with the history of space travel. And human travel really started with the Wright brothers. There was hot air balloons before that, but I don't really consider that human travel because they're using hot air and they're not actually using engines or actual jet engines or anything like that. And after the Wright brothers in 1903, the 1940s, there was the development of jet engines and rockets. Then there was the Roswell incident, which we don't really know if that was real or not, with a UFO. It's still speculative. Then after that, there was the 1950s, there was development of nuclear weapons, and the beginning launch of Sputnik in 1957. After that, there's the Mercury and Gemini missions from 61 to 66, which orbited the moon and carried a 1 to 3 crew missions. After that was the Apollo program, and 1960 to 1972 was the moon missions. Then of course there was Skylab after that, from 64 to 73. After that was Apollo Soyuz, which was 71 to 75. The space shuttle was 1972 to 2011, and that was the first reusable spacecraft. Then there was the space shuttle, with the Mir station program, where they worked with the Russians to work on that space station from 1995 to 1998. And then there was the International Space Station, which is still up there today. And once they discontinued the shuttles, they moved to SpaceX and Blue Origin and for commercial and NASA missions. And now we have Artemis, which is the next program to the moon, which they're going to send men back to the moon. Some of the types of travel that isn't human are the satellites and the probes that have gone out there. There's Pioneer 4, which became the first unmanned spacecraft to leave the Earth's orbit. In 1961, did a lunar flyby. Then we had the lunar orbiters in 1966, the Surveyor program in 1966, which were the lunar landers designed to study the moon's surface before the actual astronauts went there. Then we had the Venus probes and the Mariner missions, and then Mercury probes from 74 to 2000 with Galileo and Messenger probes as well that went to Mercury. And then we had Mariner, which is explored Mars and beyond. Viking, which was the first Mars lander. And if you're in your 50s or 60s like I am, you can remember when we first landed on Mars and those first pictures of Mars, how amazing they were. And after that was the Cassini probe, which went to Saturn and Neptune and Uranus, and took pictures of Titan and some of the other moons. And then there was the solar probes, which, well, the solar probes have started from 61 and we're still using them today, and they basically study the sunspots on the sun and solar activity. And then they built the Hubble telescope, which you're able to see into deep space. And after the Hubble, there was the Kepler probe, which used transient methods, which is basically the shadow moving in front of the sun to determine if there's a planet there. After that, we had some comet landers. And now we have the James Webb telescope, which, if you've had a chance to look at some of the pictures, are totally amazing. And that will look for atmospheric conditions on faraway planets. And we had the Mars rovers, of course, the Curiosity and Endurance, and the Mars helicopter, which they just had a lot of success with. And then, and in the future, we'll be doing the manned mission to Mars. Some of the propulsion systems which we use today are solid and liquid rocket fuels, which are basic rockets use aluminum powder as a fuel, aluminum perchlorate as the oxidizer, and iron powder as the catalyst. The solid fuel is pumped into an oxidizing chamber where the ignition sets off an explosion in the combustion chamber. Liquid rockets use the same principle, using liquid hydrogen and liquid oxygen, releasing water, which allows it to launch. And a lot of our moon rockets used the second. They used liquid rockets. Other forms of propulsion used today: ion propulsion, which uses a radioactive isotope to power very small spacecraft, such as probes. It's not very efficient for manned space missions unless the momentum is enough to increase the speed. It would have to go for a long, long time. It's still slow compared to solar sails or antimatter drives. Solar sails are under development. One has recently been used, but there are drawbacks because solar sails, you have to be within the range of the sun, and once you leave the range of the sun, they're no longer active. Regular solar propulsion, which is only reliable in the sun's range. We can't talk about propulsions of the future without talking about types of civilizations. The first type of civilization is type 1 civilization, which harnesses the energy of a planet. So that's basically, they use wind, solar, electric, but there is no waste from the product, which right now that's impossible, but that would be a type 1 civilization if they found a way to produce energy without waste. And type 2 civilization would harness the energy of the star, 10 billion times the energy of type 1. And when we think of a type 2 civilization, we think of Dyson spheres. If you know what a Dyson sphere is, it basically surrounds a sun or a spaceship, and it uses the power from the sun to power either the spaceship or the planet. Type 3 civilization harnesses the energy of a galaxy, 10 billion times the energy of type 2. And this is like Star Trek. They're able to manipulate matter to go from the ship to the planet, or from one part of the galaxy to the next part of the galaxy. That type of civilization would be able to do that. Earth right now is considered a type 0 civilization because we haven't even achieved step 1 yet. Some propulsions of the future. Electromagnetic propulsion, which accelerates an object by using the utilization of electrical currents and magnetic fields. It can reach the speeds of 200,000 miles an hour. And some of the pros of this type of propulsion is it allows aerial maneuvers in gravity-based atmosphere, travels much faster than traditional nuclear rockets. A lot of the UFOs that people see, or supposedly see, they think they may run on this type of propulsion. It's typical of a type 0 civilization or type 1 civilization. We aren't too far from achieving this type of propulsion, but we still have problems with it. And it takes 3,000 years with this type of travel to reach the nearest star. Another propulsion of the future is fusion. Fusion reactors release a huge amount of energy that can easily travel to speeds of 100,000 miles per second. It also uses hydrogen propellant as the key reactor source, which is readily available throughout the universe and can be used as they go. Some of the pros are it's faster than fission, and it reuses the sources of energy. The cons are you're still unable to reach the stars, and the ship must be very large. This is typical of type 2 civilization, and it would take 40 years to reach the next star. Then, another type of propulsion system is solar light sails, which we use now, and it pushes the large sail, collecting photons from the sun, and uses the solar wind to navigate. Some of the pros are it's great for smaller missions, and it can be built right here on Earth, but it's not practical for longer space flights. Photonic drives are similar to similar to solar sails, but they use a laser to push the sail through space without the need of the sun. They use electromagnetic radiation to generate lasers capable of pushing a spacecraft. Some of the pros are they can achieve near a third light speed with time, and they are able to propel a ship to Mars in 3 days. The cons are they're very expensive to build, inefficient to generating a continuous light source. And these are typical of a type 2 civilization. With photonic drive, it would take 70 years to reach the nearest star. Another type of propulsion system is matter, antimatter, uses a chain reaction when matter and antimatter collide and cause a powerful reaction which converts 100% of the energy of mass into the energy. The pros are you can travel at the speed of light with no waste, but the cons are antimatter is very hard to produce and very rare, and there's a larger chance of accidental imploding. And this is typical of a type 3 civilization, and we would be able to reach the nearest star within 3 years. Warp drive engine. When we think of warp drive, we think of Star Trek, of course. where they use a bubble around the ship to pull the space in front of the craft and push the space at the back of the craft to beyond light speeds. You can use antimatter to achieve light speed and then warp drive to bend the space around the ship. Some of the pros to this type of travel would be it allows faster than light travel without actually moving physical matter, and you would be able to reach stars within weeks or months. Some of the cons are time dilation is a factor. By the time you return back to Earth, everyone you knew would be dead. It's typical of a Type 3 civilization, and you would be able to reach the nearest star in 3 years or less, depending on the warp speed. Von Neumann probes are self-replicating probes or robots that stretch across the galaxy or the universe by using the resources available on comets, asteroids, planets, or moons. Some of the pros are they can be used to explore parts of the galaxy otherwise unreachable. They can be used to build colonies before the arrival of humans. We don't know, the cons are we don't know enough about artificial intelligence to say that there might not be problems with decision solving. Being so far away from Earth, it is not like we can correct the malfunction of the equipment. Who's to say that a higher developed race could not solve these issues, however? It's typical of a Type 3 civilization, and you would be able to reach 1/10 of the speed of light and would arrive at the nearest star in 30 years. Planck technology or wormhole travel, which is my books talk about wormhole travel and multi-universes and stuff like that, and that's how they get back and forth. A generation of a wormhole uses the power of the sun and dark energy to open a hole in space. The pros to this, and we also think of Stargate when we think of wormholes. Some of the pros are instantaneous travel to worlds light years away. Some of the cons would be wormholes are highly unstable, and you possibly might die through the process. The easiest way, and you've probably seen this before, to describe a wormhole is if you're traveling from here to here, you just basically bend the space in half, and you would go here, and you would be here in like a second. And that's typical of a Type 3 civilization, and you would be able to reach anywhere within seconds. Other methods of travel, possible methods, are generational spacecrafts. These are ships using fusion or slower form of propulsion in unison with a self-maintained ecosystem on board, as well as cybernetic and cryostasis equipment. They can be used for generational living on board, or the people can be frozen during the journey. Ships like these usually have a large greenhouse on board or some type of thing they would use to feed the people. And some of the pros would be they allow longer missions within solar system or beyond. They allow more in-depth study of planets, asteroids, and comets. Some of the cons would be there's more opportunities for error or accidents, disease, or prolonged exposure to radiation or starvation. This is typical of a Type 1 civilization and can take anywhere from 3 years to 3,000 depending on the destination. Now, when we look at all these, we ask ourselves, what is really possible and what isn't possible? Well, what we once believed to be science fiction has slowly become reality. Cell phones, computers, lasers, the health watches, they're just like little tricorders on your wrists. And certain technologies, however, are still hundreds, if not 1,000 years beyond our reach, such as wormholes. That's something we have no concept of learning how to do yet. Light sails, electromagnetic drives, and fusion engines are all possibilities for future travel. Theoretically, light travel can only be achieved if the problems of creating and containing a warp field during the acceleration and slowing down the craft can be solved. Wormholes are highly unstable, and dark or exotic energy must be used, and right now we haven't found either. And same with antimatter, it's scarce, and you need the dark or exotic energy to find, and we haven't found any of them yet. And that's all the propulsion systems. Now I'm going to do a little short segment on writing science fiction. And the types of science fiction, there's hard science fiction and soft science fiction. And the hard science fiction is based heavily on technology and science. It's based on extensive research of the subject, and it must be feasible by current science, or at least in theory. When we think of hard science fiction, we think of Gravity, The Martian, 2001: Space Odyssey. They're things we can believe could happen, even though they are still science fiction. Soft science fiction is based loosely on science, usually more about the people than the technology. Sociological aspects are weaved within the story. Some examples of that are The Arrival, God Themselves, and Star Wars. Which Star Wars I consider more like a space fantasy or a space opera type thing. And some of the subdivisions, I'm not going to go through all of them, but as you can see, there's a lot of them up there. These are just some of them. You have like alien invasion, dystopian, colonization, artificial intelligence, first contact, and so on. Some elements of science fiction. They're based with realistic and fantastic details. They're grounded in science and scientific methods. They're usually set in the future, but they can be set in the past or present as well. They usually contain unknown inventions. They make serious comments about the world or the galaxy or the universe. Sometimes a warning to mankind. Sometimes about exploration, and sometimes about speculations if something did happen, what would happen after that. World creation. Basically, maps can be very useful, even in science fiction. Galactical maps, world maps, town country maps, they all define places and boundaries. In science fiction, the time and the setting can be anywhere or any place, anytime, from Earth to some faraway galaxy. Make sure the rules of your world follow the rules of science, such as you cannot breathe the air on Mars, but if you adapt a station there with growing stuff and learn how to shield against the radiation, you could live there. Some of the rules of magic, unless you're writing a true fantasy story, try to stay away from using magic without a scientific explanation. And this would be like levitation, telekinesis, telepathy. They all use the mind, so it wouldn't be like magic. Or in my books, I use a drug that they take that enhances their mental abilities, and that's kind of like Dune, similar to Dune. Some of the rules of starflight. Of course, we all know energy equals mass squared. Einstein's theory that anything that travels at the speed of light turns to pure energy. Without folding the space of time, you can only travel to 2/3 of the speed of light, providing the ship has the adequate machinery to do so. To fold space and time, you need a negative energy field bubble around the ship. Warp drive, well, I said that earlier, warp drive pulls the ship and pushes it. Creating a wormhole or using a black hole can cut time considerably. Generational ships are more likely to be the ships of the future, where they transport humans to another planet or another star, and you would have one generation, then the next generation would take over. By the time you got there, it might be like your great-great-grandkids that would arrive there. Some stories, they use tesseracts or doorways through time and space, like Doctor Who. is an example of that. Cryogenics, sometimes used to make the toll on the human body more tolerable and feasible. And time dilation is a big factor. So 3 years in space would equal 5 years on Earth. Rules of time travel. If you go back in time, anything you change in the past will alter the future and the outcome of others' lives as well. Traveling in time causes you not to exist because you are traveling outside the normal time stream. If you go back far enough, changes won't have a major effect on your own time because time has an inertia that gets it back on track. You cannot go back in time and kill your grandfather. You will cease to exist. It is possible to travel to the future, however, to assassinate your older self. You cannot travel back in time before the time machine exists. And I think the new time machine that I saw, the last version of it, they did exactly that. And I don't know how they could have done that. The time machine wasn't even built yet. But they did somehow. You should know the history of your worlds. I'm not going to get into all that, but you should know your government, your language, your biography, your characters, especially your biography, your characters. You want your characters to have the history. You want the reader to know their back history, but don't go too far into it because you'll bore the reader. The scenery is important. Planets, know your planets. Any planets you have in the book, make sure you know what their atmosphere is like, their gravity, their distance from the sun, how long the years are, and stuff like that. Story construction. Who hurts the most in the story? The pain and suffering drive the main character to change his outcome. Who has the power and the freedom to act? Someone who can see through the struggle. The protagonist. You want the sympathy to be drawn to the main character. The viewpoint character is the one telling the story. Could be the narrator, could be another character, could be the main character himself. The mice quotient, which is basically milieu, idea, character, and event, which basically the milieu is all the elements that came up during your world creation phase. The idea takes the new bits of information that are discovered in the process of the story by the characters who didn't previously know that information. And the story starts with raising a question and ends with a question answered. The character goes through a transformation during the course of the story. And the event, there is a problem in the universe or the planet that needs to be solved. The process, which I would call 3 E's, is exposition, the explanation of the idea, the exploration, expanding on the idea, and the execution of writing the story. Some final thoughts. Know your audience that you're writing for. Make the science integral to your story, but not overwhelming. Show your characters' motivations, what drives them to do what they do. Introduce the problem early in the story. And this is important because if you don't get right to the crust of what the story's about, you're going to lose the reader right away. You know, that should be right on the first page, present a problem and deal with it. And create believable characters. Take us to a new time and place. Take us somewhere we haven't been before in the galaxy or the universe. Push your hero to the limit and create a strong climax. Now, a lot of these things I got from writing are basically from this book here, from Orson Scott Card, How to Write Science Fiction and Fantasy. And the rest of it I got from NASA. And here's my website, and you can find me on Amazon and Barnes & Noble, and my Twitter's there, and my YouTube. On my YouTube, I usually do readings, I do instructional videos on writing and how to format books, how to publish them, and all that. And So that's all I have. I have books at the back if anybody wants to buy them. And that's about all I have. So any questions? Excuse me.
So let's see, are there any questions here in the audience? I know because we have at least one question from our live stream. So here I'm going to hand this over to Jeremy.
All right, so our one question from the live stream so far is from Randy, asking, are there plans to try out a warp drive? Is there any major scientific research that's going on at the moment?
Yeah, they are, but they can't get, they haven't really figured out how to do that yet. I mean, they're working with the CERN on trying to do that. But as of this point, they haven't got there yet.
Haven't made the breakthrough.
Right.
Yep.
Right. And I doubt they will for probably 100 years, at least, or better. So, yes.
Consider Twilight Zone science fiction?
Some of it. Some of it. Yeah.
Repeat the question.
Yeah. Could you repeat that?
No.
Oh.
You repeat it.
Oh, God. Yeah. He wanted to know. He wanted to know if Twilight Zone is considered science fiction. Some Twilight Zone is science fiction. Then other Twilight Zone is just it's something different. You know, it's, I don't know how to describe it. It's just I've seen like shows about the devil on there and other things too. So it's not all science fiction.
Some of it could actually happen without any new inventions or
Right.
Microphone there we go. What I wanted to just mention, for those people that are on the live stream that aren't from the upstate New York area, Rod Serling, who was the creator of the Twilight Zone, actually grew up here in Binghamton. And so I think he has a special a place in Binghamtonians' heart because he grew up here. In fact, I believe the theater down at Binghamton High School, I know they do a Rod Serling film festival every year, and so trying to think if there's any other questions either on the live stream or you have the question here? Yeah, hold on.
Yes.
So you had this slide about describing the rules of time travel. I think the last rule was you can't go back in time before the time machine was made. Could you kind of explain why that is?
Because the technology that isn't there to send you back. So if you build a machine, like say you built a machine today, there's nothing there that would get you back to where you wanted to be. In other words, because the machine wouldn't exist yet if you went back. Yeah, basically, yeah.
All right, we had a question in front.
So when you're writing your science fiction, do you ever get in your head about what is some physicist going to think about the concoction I'm putting together in my technology? Is it going to be plausible?
I do sometimes.
Am I going to sound stupid?
Yeah, I do sometimes. Sometimes I'm kind of apprehensive about it, but that's why I do my research. I do, like when I was doing warp drive in my books, I actually found the formula for the warp drive, and I figured it out from there. So in Star Trek, you may see them go somewhere and be there in 3 days. Well, if you're going at warp 3, it would take longer than that, depending on how far away you are. So like a lot of my books are like 12 light years away from each other, and it would take probably 3 to 4 months at warp 3 to get to that point. So it's not like an overnight thing. It would take a while.
Well, to that end, the author of the book The Martian, Andy Weir, I saw an interview of him, or they were interviewing him, and he was saying that when he was writing this, he just had Neil deGrasse Tyson in his head, thinking, okay, he's going to read this, and I better, and I'm paraphrasing this, I better science the daylights out of this out of this story, and so I guess it was well received by Neil deGrasse Tyson.
Yeah. And speaking of him, with the Dyson sphere, what I want to say about that is there's a really good movie that just came out, Moonfall, and they dwell on that idea. They go into the idea of the Dyson sphere, and they elaborate on it, and it's a really good movie, that one. So.
All right. Unless there are any other questions, yeah, we do. Okay, we'll continue.
I was a little curious. I don't think that I quite understood the last time travel rule concerning you can't go back and like kill your grandfather or else you will cease to exist.
Right.
But you can go back and assassinate.
Well, no, you go in the future to assassinate yourself.
Future to okay.
Yeah, you can't go back in the past to do it, but you can in the future.
Right, okay.
So your younger self would go into the future. In fact, I saw a movie like that. I can't remember what the name of the movie, but he actually went back. He went into the future to assassinate himself.
Okay, I missed the future part, so that is where the root of my confusion was.
Yeah.
All right. Well, unless there's any other questions, I did poke my head out, and I did see the moon. So we have a rule here is that you cannot leave Kopernik until you look through a telescope. So we're going to have to give me your keys, and I'll get them back after you look through the telescope. Anyway, no, we invite you to come outside and join us in our 6-inch telescope to see if we can get the moon, but we could also continue a telescope tour for those especially that are here for the first time. And Nicholas, I want to thank you very much for
You're welcome.
For your presentation.
Thank you very much.
He will be in the back with his book, so if you'd like to consider purchasing a book, and I'm sure he'll be happy to sign it for you. And for those, for next week is technically the Perseid meteor shower. Now, it's not the greatest year for that because we'll be just past a full moon, but you never know. There's still some good good meteorites waiting to come in, and so if it's clear out, we will be open on Friday. So check our website for that. That will most likely not be live streamed, but and we are in the process of working on finalizing our schedule for the fall. So again, thank you for joining us on the live stream. Thank you for joining us here in person, and look forward to seeing you soon. Thanks.